Alright, in this video I'm going to solve some linear inequalities, just run through some examples. Here's the first one, 2x plus 5 bigger than or equal to 10x minus 19. So you've seen equations. If this was an equal sign, this probably wouldn't be a difficult question. So it shouldn't be a difficult question if it's a greater than sign, so you're going to solve it the exact same way. You need to get all the x's on the same side of the inequality. So in this case we're going to subtract 10x from both sides of the equation. So we'll have 2x minus 10x plus 5 bigger than just bigger than. The 10x's cancel. Bigger than negative 19. So we have minus 8x plus 5 bigger than negative 19. Now we need to subtract 5 from both sides. So we have negative 19 minus 5 on the left side and minus 8x on the left side. So we have negative 8x bigger than negative 24. Right? Minus 19 minus 5 is negative 24. And we'll just divide both sides by negative 8. Remembering that when you divide both sides of an inequality by a negative number, you must divide by negative 8. You must switch the inequality sign. So the negatives cancel here. So we have x is smaller than negative 24 divided by negative 8 is 3. Or if you wanted to write it in interval notation, x is in the interval from negative infinity to 3. Open bracket, because it's a strict inequality, strictly less than. Or you could write it on the number line. Oh, sorry. It's 3, so I should probably 1, 2, 3. We want to not include 3, so we get an open circle at 3. And everything less than 3. So all these numbers, and just throw an arrow in there. Okay, one thing you should be aware of when solving these equations is, notice at the beginning I chose to collect my x variables on the left side of the inequality. Doesn't really matter what you do. If you had done it on the right side, you would have ended up with something like this after you'd done a few steps. You would have ended up with 8x on one side and 24 on the other side, and you would have had a greater than symbol. Then you would have divided both sides by 8, and you would have had 3 is bigger than x, which is the same thing we have over here when we said x is less than 3. So notice this and this are the same thing really, but sort of by convention you wouldn't put the x variable second, right? Saying 3 is bigger than x isn't sort of intuitive, because really you want to tell me what x is, like what the x values are. So saying 3 is bigger than x, I mean it's true, but it's sort of is more, it explains the situation better if you say x is less than 3, right? Even though saying 3 is bigger than x is the same thing as saying x is less than 3. Sort of by convention, when you're solving an inequality, your variable should go first. Okay, we'll solve another inequality. Here's an example of what we'll call a double inequality. So we've got 10 less than or equal to, sorry, not 10. We'll start with 25 less than or equal to 2x plus 5 less than or equal to 29. So there's two inequalities here, right? There's one inequality here and one inequality here. So what you could do is solve them both separate. You could break this up into one inequality, 2x less than or equal to 25, or 2 plus 5 and solve that inequality. And then there's another one, 2x plus 5 less than or equal to 29, and solve this inequality. So you could solve both these inequalities separate and then combine their answer at the end, but what's actually easier to do is to just solve them at the same time. So just isolate for x in the middle inequality. So we just want to isolate for x here. So in order to isolate for x, you do the same thing you would normally do. You'll subtract 5 from all sides of the inequality, so from the middle and from the right side and from the left side. So in the middle, the 5's are going to cancel and you're just going to have 2x. On the right side, you're going to have 29 minus 5. And on the left side, you're going to have 25 minus 5. So on the left side, that's 20 less than or equal to 2x less than or equal to 24. Now divide the middle by 2. So you have to divide all the inequalities by 2, or both the inequalities by 2. So you're going to have 10 less than or equal to x less than or equal to 12, meaning x is bigger than or equal to 10 and smaller than or equal to 12. So if you wanted to write that in interval notation, you say x is between 10 and 12 using square brackets because it can include 10 and 12. Or if you wanted to write that on the number line, 10 will be here, 11, 12, let's say 13's there, 9 is there. So we want to include 10 and 12, so we're including 10 and 12, and any number in between there. So any number in this interval should satisfy this original equation. Right? If I took a number between 10 and 12, say 11, and I put it into this original inequality, then I should get a number between 25 and 29. And really anything between 10 to 12, including 10 and 12, should work. Okay, so that's a double inequality. Here's another example of a double inequality, which might not look like a double inequality at first. This one with an absolute value. Absolute value of x plus 1. Let's go with less than 4. Okay. And you might be saying, well, why is this a double inequality? Well, remember back to an example like this. Let's say we had absolute value of a is less than 4. If you go back and you remember when we did absolute values, we said this is equivalent. This is the same as saying a is less than 4, but bigger than negative 4. So we can do the same thing with this one. We would say x plus 1 is less than 4, but bigger than negative 4. And that's just because if we think about sort of the cases where this could be x plus 1 could be positive or x plus 1 could be negative. I'm not going to go through the whole, looking at the cases. Go back and look at why this is true if you don't remember, and then you'll see why this has to be true. And then we just solve it the same way. We subtract 1 from everywhere in the equation, or in the inequality, all the inequalities. So x is less than 4 minus 1, and bigger than minus 4 minus 1. So x is bigger than negative 5 and less than 3. So any number between negative 5 and 3, not including those two numbers, if I sub that in for x, that should make this inequality hold true. Okay, so that's another example. Third example, or is it a fourth example? This is just another one that you've seen equations like this, and I'm going to make it a inequality, and you'll solve it much the same way you would an equation. Okay, so we have an inequality. On both sides of the inequality is a rational expression, so meaning it's a fraction, there's denominators. So one thing people sometimes do when they see an equation like this is they do what sort of a trick of what you call cross multiplying, where you multiply 6 by the denominator here by the numerator and the numerator here by the denominator. Now a lot of teachers don't like it when you do cross multiplication, and some people say, well, why not? It works. Well, it works for equations, but when you get into inequalities, cross multiplication is going to cause you problems. And the reason cross multiplication would cause you problems is, remember, when you multiply by a negative, both sides of an equation by a negative, you have to switch the sign. Well, x minus 3, depending on what x is, might be positive, might be negative. Same with x plus 9. So you'd have to consider all these cases where if this one's positive and this one's negative, and that's just a lot of work. So don't cross multiply on inequalities. I'm going to write that as a rule. Don't cross multiply. And the reason cross multiplication is really just a shortcut, and the problem with inequalities is by doing that shortcut you lose sort of cases. So really this is one reason why we always say, why a lot of teachers make a big deal about don't cross multiply. So what are you going to do? Well, still, you don't like these denominators. So what you can do is just sort of multiply by a value which will get rid of the denominators. And you may or may not have seen this when you solve equations like this. You can multiply by the least common multiple. Least common. That's not how you spell common. Common multiple of the denominators. There's an I in there. So the least common multiple of 6 and 3 would be 6. So if you multiply both sides of this equation by 6, and that's not an issue because 6 is a positive number, so we don't have to worry about switching the inequality sign. So on the left, 6 and 6 here will cancel, and you'll have x minus 3 bigger than or equal to, and on the right, 6 divided by 3 is 2, so we'll have 2 times x plus 9. Now if we just expand on the right, we'll get 2x plus 19, multiplying the 2 into both terms, x minus 3. Now we just need to collect like terms, so I'll collect on the left side. So I'll subtract 2x from both sides of the equation, or inequality, sorry. So I'll have 18 on the right side. On the left side I'll have x minus 3 minus 2x. So I'd have minus x minus 3 bigger than or equal to 18. And now I just need to add 3 to both sides of this equation. So I'll have minus x bigger than or equal to 18 plus 3 is 21. I need to divide both sides of this equation by minus 1. And when I divide by a negative, I switch the direction of the inequality. So I have x less than or equal to negative 21. So the solution to this original inequality, way up here, this one here, is all numbers less than or equal to negative 21. So if I put any number less than or equal to 21 into this inequality, that would solve my inequality. Or if you wanted to write it in interval notation, x is an element of the interval from negative infinity to negative 21 with a square bracket, because you can include that. Or just, because I do it every other time, the negative 20, negative 20, negative 21, negative 22. You want to include negative 21 and then take all numbers less than that.